Hello, so we're going to continue looking at topic 6, which is groups of the periodic table. We're going to focus today on group 7, which is the halogens. So please make sure your mobile phone is not going to distract you, so it is put away, turned on silent or off. And you've got a pen and paper to take some notes and have a go at answering the questions. If you're ready, we will begin. So we're going to have a look at the group 7 elements, and these are these ones down here. So they are in group 7. It tells us group 7 at the top of the periodic table. You'll get this in the back of your exams. And it is these ones all here. So fluorine, chlorine, bromine, iodine, and astatine that are there. Now, just like the group 1 elements, they have a name, and they are known as the halogens. Now, halogens means salt maker in Greek. Now, within your exams, you will get a question asking you to name one of the groups, or which one is known as what, either group 1, group 7, or group 0. I don't know which one, but it will be one of them. Now, they all have similar properties. So if you think back to Mendeleev, he arranged all the elements, or the known elements, into groups with elements of similar properties. So they all act in similar ways. And that is because they all have 7 electrons in their outer shell. So they have 7 electrons in their outer shell. They're in group 7. A full outer shell would be 8, obviously. They've got 7. So they're nearly there with the full one, and they are non-metals as well. Now, they all form -1 ions. So they've got a -1 charge because they gain 1 electron. They gain 1 electron to get a full outer shell. So therefore, they have a -1 charge. They've taken away an electron from something else, so it's take away minus, taken away 1 electron, so we've got a -1 charge. Now what you need to know their formulas for these 3, chlorine, bromine and iodine, their state at room temperature, so whether they're solid, liquid or gas, and their colour as well. It seems a little bit odd, but the exam board want you to know it, and it comes in useful for doing a few things later on. So have a go, see if you can write down what all they are. Pause the video quickly and have a go. Okay, so hopefully you've had a little go at trying to do it. Let's have a look at the formulas, states and colours. So chlorine has the formula Cl2. It is diatomic. They always have this little 2 after them. They always come with that 2 because they go round in pairs. So that 2 down there, subscript right at the bottom. Now, chlorine is a gas at room temperature, and it is a pale green colour. For bromine, hopefully you've got that as Br2, again that little 2 there. It is liquid at room temperature, and it is a brown liquid. That one, helpfully, we've got bromine, starts with a Br, brown starts with a Br as well. You can also say orange as well, but I think brown makes it a bit easier to remember. They both start with Br. And then iodine, we've got it as I2. It is solid, and then its colour is purpley black. So we have a few things there. They're all there as diatomic molecules, so they all have a 2 on there. State changes as we go down the group. We get gas, liquid or solid because our melting point increases down the group. So as we go down the group, melting point increases. So our melting point increases. And then our colour, as we go down the group, it gets darker. So we're getting darker as we go down the group. If we would think about what astatine would be, it would be a really, really dark black colour, and definitely solid as we get down there. We're going to have a look at how to test for chlorine gas. So I've got a test tube here, and we're going to imagine that it is filled with some chlorine gas. So my chlorine gas is a green colour. I'll just draw a few bits on there. So we've got it in there. Now to test for chlorine gas, we need to use some damp blue litmus paper. So there we've got our damp. So it's been put under a bit of water. It's the blue litmus paper. So we've got damp blue litmus paper. And for that, we see the following things happen. First, we see it turn red. and then we see it bleached white. So we start off with blue litmus paper, it turns red and then white. So we've got damp blue litmus paper, and it will turn red, and then it is bleached white. And that is our test for chlorine gas. Now we need to be careful when we're doing this, because chlorine is toxic. So it may cause harm to anyone that breathes it in. So if we're doing this, we want to do it in a well-ventilated room or in a gas cupboard or a fume cupboard. So it sucks all of the gas out and we don't breathe it in. So we can do it in a well-ventilated room or in a fume cupboard. We're now going to have a look at how the halogens react with metals. And we've got a generic equation there. We've got halogen plus metal will make a metal halide. So careful bit to pay attention to there. It becomes a halide. So it changes its ending to IDE. So an example there is sodium plus chlorine makes sodium chloride. Again, notice I've changed my chlorine, so my INE to an IDE. And I've got my balanced symbol equation there. So 2Na, which is solid, plus Cl2, which is gas, makes 2NaCl, which is solid. This NaCl is my sodium chloride and is salt that we commonly know it as. It's an ionic compound. There is an image of it happening. So it happens, it's a very, very big reaction, very vigorous reaction. So we get a bright orange flame and we get lots of white smoke. That white smoke is the sodium chloride. It's a very, very vigorous reaction. Now, bromine and iodine won't react as vigorously, but they do react in similar ways. So what I'd like you to do is have a go at trying to write the word and symbol equations for these two reactions. Please pause the video and give it a go. Okay, so you should now only be watching if you've had a go at writing those equations. So sodium plus bromine makes sodium bromide. So notice again we've got that IDE at the end. And then my equation here, notice my state symbols. My bromine is a liquid. And then sodium plus iodine will make sodium iodide. Again, we've got that IDE and my equation there. Notice that when I'm bouncing my equations, the majority of the time it is the number 2 on there that we use to balance it. Majority of the time it is the number 2. Not always, but the majority. Now my halogens can also react with hydrogen to form something called hydrogen halides. So if I had hydrogen plus chlorine, I'm going to make hydrogen chloride, which is also known as just HCl. So that's hydrogen chloride. I can do the same with hydrogen and bromine and make hydrogen bromide, and I can make hydrogen iodide. Now these can all be just written as gases, but they are all soluble. So if I put them into water, because they're soluble, they will dissolve. And we've got now hydrogen chloride dissolved in water, hydrogen bromide dissolved in water, and hydrogen iodide dissolved in water. Now when they're in water and they dissolve, they split up and we get H plus ions and negative halide ions. Because we have H plus ions, we've made an acid. So we've now made HCl, which is aqueous. We've made HBr, which is aqueous. And we've made HI, which is aqueous. Now these are no longer known as hydrogen chloride, hydrogen bromide and hydrogen iodide. They are now acids. So we have our first one here, we have hydrochloric acid. Hydrogen bromide would be hydrobromic acid. And hydrogen iodide would be hydroiodic acid. Again, notice we've changed the suffix, but we've made an acid. Now, they sometimes ask questions about this just to try and throw people, but if we have something with hydrogen in, so hydrogen something added to a solution, it becomes an acid. We can think of what we can change it to. We know that hydrochloric acid, so it's aqueous, we know it's hydrochloric acid. We can then go, right, we've got hydrobromic and hydroiodic acid as well when they dissolve in water. That bit is quite tricky. We're now going to have a look at some displacement reactions. And this bit does get a bit tricky, but it probably will come up because they like it in the exams because it really, really stretches people. So I've got a white tile here, and I've put down what solution I'm going to put in each one. So I've got potassium chloride, potassium bromide, and potassium iodide solution in each one. I'm going to add each one into it now. Okay, we've got them on there. And you'll notice that they are essentially a colourless liquid. And we're now going to add either some chlorine water, some bromine water, or some iodine water. So this one I'm going to add chlorine water. That's just chlorine dissolved in water. If I add the chlorine water to potassium chloride, we get no reaction. If I add my chlorine water to potassium bromide, I see that I get sort of a yellowy orangey liquid forming. So it will change colour a little bit. And then if I add it to potassium iodide solution, I get sort of a browny blacky colour sort of appearing. So sort of orangey black is going to appear there. Let's try and get them both on together. So we get that appearing. We have displaced the less reactive elements. So it will displace the less reactive halogen. Now for my second row, I'm going to add bromine water. Now for my first two, I get no reaction. Nothing changes. But for my potassium iodide, I do get a bit of a change. I get sort of this blacky, browny, reddy colour. I'll try and sort of add them all in together. So we do get a reaction. And my last one, I'm going to add iodine water. And what I see for all of these, across all of them this time, is no reaction. Now, things you might be asked to do are to explain this experiment. You get your potassium bromide and we add chlorine, bromine and iodine waters and look for the colour change. You may be asked to say what colour change you get. For your colour change, you go from colourless to, for our bromine, you get sort of an orange colour or orangey yellow. And for your iodine, it goes to sort of an orangey brown. I know those colours don't completely match up to what we did earlier, but when they're in solution, they are diluted a little bit. So the colours get a little bit lighter for them. You may also have to write an equation for it. So our more reactive one displaces our less reactive one. So if I had chlorine plus potassium bromide, I'm going to displace, my chlorine will displace my potassium bromide. So that will displace the bromine. All we're doing is switching them over. So we then make bromine plus potassium chloride. So we'll displace it over. We would get a colour change as well, going to sort of an orangey yellow. And we may have to write what we call an ionic equation. And that's what we're going to do now. We're going to have a look at ionic equations. So to do an ionic equation, they will often give you the equation, and you'll notice here that it is balanced. And what we need to do is we need to write out the equation with the ionic compounds as their ions. Now my ionic compounds are my sodium bromide and my sodium chloride. So those are my ionic compounds. I need to split them up into their ions. My atoms, I leave them as they are. So I've got Cl2 plus 2. I've got Na. Sodium is in group 1, so it forms an Na1 plus ion. And I've got 2, as that 2 still links to that one there as well. It links to both of them. 2 Br minus ions. It's in group 7, so it forms a -1 ion. It's going to make Br2, that's not an ion, I can leave that as it is. Plus, I've got 2 sodium ions. Again, it's in group 1, so it's going to be a +1 ion. Plus 2, again, that 2 refers to everything in this compound, Cl minus ions. I'm now going to cross out any ions that appear on both sides. So my Cl2 is only on the left. My 2Na plus is on the left and the right. So I can cross that out on both sides. And my 2Br minus only appears on the left, not on the right. I can then write out my equation as it is here. So I've got Cl2 plus 2Br minus is going to make Br2 plus 2Cl minus. This is an example of a redox reaction. Redox reaction refers to both reduction and oxidation. So I've got reduction and oxidation. And hopefully you'll remember that reduction is gain of electrons and oxidation is loss of electrons. So we see that change happening. We wanted to work out which one has been oxidized and which one's been reduced. So my chlorine has gone from a chlorine atom to an ion. To go for an ion, it's got a minus charge, so it needs to have gained an electron. So my chlorine has gained an electron. Because it's gained an electron, it has been reduced. And my bromine has lost electrons to go from being a bromide ion to a bromine atom or a bromine molecule. So this has lost an electron. Check, it's lost 2 electrons because we've got 2 bromines there. So we've lost electrons. So therefore it has been oxidized. This bit is tricky. If you can't remember which way round they go, just say it's a redox reaction because reduction and oxidation has happened in the same reaction. If you can work out which one it is, write that down because you will get some more marks. So our final little bit of theory is to have a look at the reactivity of them and what's going on. Now I've drawn out the atoms, chlorine, bromine and iodine, and we can see that they're getting bigger. And we can say that reactivity decreases going down the group. So it's the opposite to the group 1 where it increases. These ones decrease going down the group because the atomic radius increases. Now our atomic radius is the distance from the nucleus out to the outermost shell. group 7, so they've got 1 of 7 electrons in their outer shell. It means their outer shell is further from the nucleus. As such, there is a weaker force of attraction between the nucleus and the outer shell electrons, or the outer shells. Let's add on an S there, apologies for that. And it makes it harder to gain 1 electron to form a 1- ion. So it's now harder to gain 1 electron to form a 1- ion. So that is how they react. They need to gain an electron. It's harder the bigger it is. It's easier to lose for group 1, harder to gain for group 7. So we've now got some questions for you to have a go at. These are from an exam paper. So I'd like you to pause the video and have a go at answering these questions. So you should now only be watching if you've had a go at answering these questions. Have a look at the answers. So for the first one, our liquid will change from colourless, so not clear, it's colourless, to orange or brown. Our ionic equation for this reaction is Cl2 plus 2I minus makes 2Cl minus plus I2. If you're not sure how we've done that, go back and watch the clip from a few moments before. Now, our explanation for why chlorine is more reactive than iodine. We've got chlorine has a smaller atomic radius than iodine, so the outer shell on chlorine is closer to the nucleus than in iodine. There is a stronger electrostatic force of attraction between the nucleus and the outer shell in chlorine than in iodine, so then it is easier to attract an electron to form a -1 ion in chlorine than iodine. I've written quite a bit there. You don't need to write quite so much, you don't have to do the comparisons as such. We want those points that the radius changes and it is easier to gain an electron in chlorine than iodine. A final bit, explain why it is an example of a redox reaction. So iodine has lost an electron to become an iodine atom, and loss of electrons is oxidation. Chlorine has gained an electron to become a chloride ion, and the gain of electrons is reduction. And I've put redox reactions involve both oxidation or reduction. Now with this part, I'll show you our marks. We would get 1 mark for saying what has lost an electron, 1 mark for saying it has the loss of electrons is oxidation, 1 for which one has gained, and 1 mark for the gain of electrons is reduction. This part here would be 1 mark only. So we can get at least 1 mark, potentially 3 marks if we say redox involves both oxidation and reduction, loss of electrons is oxidation, gain is reduction. Could potentially get 3 marks there. It kind of depends on the question and the mark scheme, but try and get as much in as you can. Well done if you got all of those correct. You will absolutely smash your exams. Take care, and we'll see you for the next video on noble gases. Bye bye.